For the given figure, segment AE and BD are parallel and angle BDC measures 58 degrees while angle ACE measures 62 degrees. In order to find the angle CAE, we know that line AC intersects the two parallel lines. Then it will make the same angle with both of these lines. So angle CAE is same as angle CBD, which can be calculated by using the property of sum of internal angles of a triangle equals to 180. Subtracting 62 and 58 from it will give us our result. If line Q is parallel to line R and both lines are intersected by line S and y equals 2x plus 8, to find the value of x, we can start by first figuring out the value of y. Since line S is intersecting the two parallel lines, it will make the same angle with them. Angle y can be calculated by subtracting 58 from 180 degrees. Finally, plugging in the value of y in the given expression, we can solve for x. If angle A of triangle ABC is 50 degrees and the triangle is isosceles, to find which of the following cannot be the measure of angle B, we first need to recall that isosceles triangles have two of its internal angles identical. So option A makes it as an isosceles triangle. Now, if angle B is 65 degrees, subtracting the two internal angles from 180 gives the third angle as 65. So that makes it an isosceles triangle as well. Similarly, 80-degree option also results in the two same angles. So option D is the correct choice as the three internal angles are 50 degrees, 100 degrees, and 30 degrees. For the triangles shown below, to figure out the equivalent ratio of BC over AB, first we could calculate angle B by subtracting the other two internal angles from 180, which is coming 58. Similarly, angle E is coming 32 degrees, making the two triangles similar. Since the ratio of the sides of similar triangles are same, the equivalent side for BC, that is opposite to angle 32, will be DF, while the side AB is the hypotenuse of triangle ABC, that will be equal to side DE for triangle DEF. If two nearby trees are perpendicular to the ground, which is flat, and one of them is 10 feet tall and has a shadow of 5 feet, and at the same time the shadow of the second tree is 2 feet long, in order to figure out how tall is the second tree, we can compare the right triangles formed by the two trees and their respective shadows. Equating the ratio of the sides of similar triangles, we can find the length of the second tree, that is coming 4 feet. For the given figure, line M and N are parallel and value of x and y are provided. In order to find angle Z, we know that the angles opposite to each other of the intersecting lines are equal. Equating the value of x and y, we can solve for k, that is coming 21. Next, since line T intersects the two parallel lines M and N, the angle it makes with the two lines will also be identical. Plugging in the value of k, we can solve for x, that is coming 139. Finally, the sum of angle x and z will be 180. Substituting the value of x will give us our angle z. For the given figure, line R and S are parallel and line M intersect both of these lines. It means that line M will also make the same angle Y with the line R here as it is making with line S. Next, we know that for a line, the sum of angle x and y will be 180 degrees. In addition, we are provided that y is less than 65. Placing the value of y in the inequality and simplifying by adding x on both sides and subtracting 65 from both sides give us the value of x, that is coming x is greater than 115. If the sides AF, BE, and CD are parallel, that means that the two quadrilaterals BEFA and CDEB are similar to one another. Next, we are given side AB as 9, BC as 18.5, and FE as 8.5. In order to find the side ED, we can equate the ratio of the sides of similar quadrilaterals. Simplifying will give us the length ED. For the given right angle triangles, tangent B, that is the ratio of the opposite side to the adjacent side of angle B, is 3 over 4. Using the Pythagorean theorem, we can calculate the length of hypotenuse, that is coming 5. Next, we are given that the side BC is 15, which is the hypotenuse of triangle ABC. This means that the triangle ABC is 3 times as long as the triangle with sides 3, 4, 5. So the length of the adjacent side of the triangle ABC will also be 3 times the length of the side 4. Furthermore, we are given that the side DA is 4. Subtracting this from 12 give us the length of the adjacent side of triangle BDE. This length is twice the length of the adjacent side of triangle with lengths 3, 4, 5. That means that the side DE will also be twice the length of the opposite side.
Can you figure out the angle X line C makes while it intersects the two parallel lines?